Hey guys, welcome back to the channel. I have another PCM here on the bench. This is for a 2000 Dodge Ram 5.9 liter diesel. Dustin Palmer from, I think it's Oklahoma. I don't have my glasses with me, but I think, yeah. Let me just see, make sure that that is correct. All right, yeah, he's from Cleveland, Oklahoma. And his concern is the PCM will not pull the ASD relay to ground. He said it's actually like intermittent. It pulls it and it releases it and pulls it, releases. So the engine stalls, obviously. The powertrain module, or PCM, in this vehicle is actually for the transmission. But so what I'm going to do in the video is I'm going to walk you through the connections, the wire diagrams, explain you how the ASD relay works on this computer. Also, I will show you, which you can also use in the shop if you're a technician, because sometimes you want to make sure that this is actually working good. It's actually pretty simple to provide the powers and grounds with the computer, even in the car, right? Because you got the battery and everything in there. But you want to make sure that you eliminate the harness, and then you can perform a bidirectional control with a scanner on the vehicle to make sure that your diagnosis is proper, right? So because we want to make sure that we're not going send a computer and then the problem is in the car. So on this one, I already talked to Dustin. This computer has over a month in here. 2000 is hard to get parts. So, and especially right now with all the tariffs and everything that's going on, sometimes it takes a lot longer to get the parts. And also I was, in Alaska, so it was not the perfect time for the computer to be here, but I finally got the part in the time to really work on it. And now I'm fixing the computer for him. So like I said, this is what you will see on the video, and then doing the bidirectional control on the bench so we can perform the test after repairs. I'm going to show you the computer out of the case, and you will see everything in there. It's pretty easy, pretty simple computer. All right, as I normally do, let me, show you the computer. I can actually make a little zoom here. And then make it go that way. Okay, so what you see here is I'm actually using a relay, even a bigger relay, because the relay for the ASD, let me get you a view of an original one. It's this type. It's a smaller relay, so I'm actually using a bigger load to over the stress the circuit, and that's what I normally do, because I want to, it's brand new drivers and everything I install. I want to make sure that everything is everything is good and is going to last. So we're going to be using also the scanner. This is a 2000, so we have communication, no problems. And I will put the meter on the screen so we can see the fiber reference and sensor ground on the computer to make sure everything is there. But let me take you over to connections. As I normally do, I create a folder for the customer. This is the notes, so you can see this again, the computer out of the board. Pretty simple, one board, or one layer of circuits, right? Not a one layer board, but it's a one layer of circuits. Just to read the concerns. PCM will not pull the ASD relay to ground, relay buzzes, and this is when it's the buzzes, so that sound is because it's not being pulled completely, so it's not closing it properly, and it buzzes. It goes like zzz, because it's not fully pulling the relay. All right, so this is also for him and you guys to see the other side of the computer. This is the part numbers and everything, and as you see here, has been since 8/23 here. All right, so as far as connections, I will show you the diagram in a second, but or my connection, sorry. I want to show you the ASD relay diagram original. So let me get a box in here so you can, I'm going to use it as a mouse. So this is the powertrain control module. This computer has also an engine control module. So this is, the powertrain is for the transmission, the engine control for the engine. This computer has 3 connectors, and the ECM is a bigger module, Cummins. There's a 2 connector, a 60 pin and a 50 pin. This has 3 connectors of 32 pins each, and we will see that in a second. So my main focus in here is to show you at the bottom the powertrain control module connector C3. It sends the ground control for the relay on connector 3, pin 3. and this is as it goes up, and we can see here the diagram of the internals of the relay. This is the coil side, the control side. On the other side, this is pin 85. Always pin 85 will be connected to ground control. Pin 86 on the other side, again on the control side, is going into a fuse, which is hot and run or in a start. And then the load side is, as we can see, terminal 30. Always terminal 30 is going to be constant battery power, obviously through a fuse, but this will be constant battery. 30 is constant battery. If it's terminal 15, that means an ignition, but terminal 30 is constant battery power, and we can see that here, right? So it's coming from the battery through a fuse, fuse 6 on the power distribution center, and it's a 30 amp fuse. When the control side commands the relay to close, this will send power onto terminal 87, and that's what I always say, you know, terminal 87 is a battery positive through a relay, so terminal 87. Remember those numbers, and that will send power to the computer on connector 3 on pin 12. All right, we also have an ignition feed in here, so if we want to see this, that we have it already here. We have an ignition on connector 1, pin 2, that's a fuse ignition, and we can see that in here. It's the same wire or the same fuse that's supplying power on the control side to this relay, and it just has a splice that is 107. Let me make this a little bigger so you guys can see that a little better. But yeah, S is for the splice, so we can see that in there, and that splice will send that over to the computer. These are the color wire diagrams, which I don't think we need to see. Oh yeah, maybe it is. Yeah, that's the next thing that I wanted to show you. So what I did is I mark in here the main signals for me to check this concern of the customer, right? So what do I need here? Powers and grounds, communication, right? So we have grounds in pin 1, sorry, in connector 1. So, but yeah, this is a little hard for you guys to understand, right? Because there's a lot of wires, a lot of stuff on the image. So trying to make it simple for all of you that are watching this video and make this. So I went and gathered all this information for all my viewers and all the technicians that are watching this video. So you can see here at the top, all the 3 connectors, they're all black. That's what it says in here. So connector 1 is 32 pins, connector 2 is 32 pins, and connector 3 is 32 pins. So the way that I found which connector was which, because I don't have the harness to make a difference on which one is which, is I follow something that is unique on one connector. So I have also all the pinouts in here. If you want to read it, I'm going to make it a little bigger so you can see all the pinouts. Let me just go of the 3 connectors. In connector C3, we have in pin, is it C3? Let me see, no, sorry, connector C1. We have, is the only one you see that has pins 31 and 32 are ground. In the next connector, in connector 2, that is actually pin 31 is 5-volt reference, and 32 is not being used. And in connector 3, it has 31 is not being used, and 32 is a speed control switch signal. So this will tell me which one is C1, and then C2 is the center one, and then C3 is the one on the other side. And that's how I found it. That's how I make my difference when I'm doing a board test, to make sure that I'm not going to burn the computer doing my connections, right? All right, so going into what is in here. So we got powers. Connector 1, pin 22 is constant battery. Connector C3, pin 12 is terminal 87. That's the same one that I just showed you on the diagram. And then also on the same diagram, we saw this connector 1, pin 2 is ignition. So these are the powers. The grounds we just discussed in here are in connector C1, pin 31, and pin 32. Communication for the scanner, or again for the scanner, because this computer has also an internal bus to communicate in between the engine computer, the transmission, and the outer modules in the vehicle, but we don't need to see that because it's not necessary for what I'm doing here. The 5-volt reference, just to make sure the computer is alive. That's very important. As a technician, if you want to make sure the computer is alive, you need to make sure the 5-volt reference and sensor grounds are good. If you go and test a computer and you don't see a 5-volt reference, you need to start unplugging outputs and sensors to see what is shorting it out. If you remove all the loads and all the inputs, and still you don't get 5-volt reference or sensor grounds, and all your powers and grounds are good, then the module is bad. You see what I mean? But you need to remove them, because an output can bring the computer down. A 5-volt reference shorted to ground or shorted to power can bring the computer down. Why? Because it's for also used for the logic internally in the board and the microprocessor. And then, well, let me just follow up. 5-volt reference is in connector C2 pin 31. Sensor ground in connector 1 pin 4. And the test that we're going to do, the ASD relay control, ground control side is connector 3 pin 3. So those are the connections that I have here. I also, for myself, because this is internally on the other side of the board, how they look, and I mark everything in there. All right, so that is just pretty much what I wanted to show you to don't make the video too long. All right, so I'm going to put the SUS here in the meter. I'm gonna have to move this a little bit this way, probably out, so we don't lose that relay, because I want you to see that. So the test light, if the relay is commanded on, should come on. This computer needs the ECM to run and have the crankshaft position sensor signal running for that ESD to be always on. So, but that is okay. So let me enter again the transmission, the PCM. This is the module that we're going to be working on. So let me move this out of here, move the scanner so I can be closer to the scanner myself. All right, automatic transmission with air condition. We're going to click OK. Oh, haven't even powered the computer, so let's power it up. And we can see the relay activation and then cuts off, which is okay. That is normal. I might have to restart the communication. We'll see. It might fail because I wasn't powering up the computer. I want you to see the 5-volt reference on the meter that I have in the next to the scanner on your view. Then now the 5-volt reference and sensor ground are present and they're good. Yeah, this is just because the scanner has not connected even to the BCI. So yeah, it finally connected to the BCI right there, because it's a wireless Bluetooth BCI. So we're going to go over into functional tests, ATM tests. There's two different ways we can check this. As you see here, we got in the upper row, the third one, it says auto shutdown relay. That is exactly that relay. So we can enter that one. Okay, no, looks like it's no communication. So am I going to have to restart? Let's try one more time. Yeah, no, I'm going to have to exit and exit and exit again. Let's see if it now is working or not. Yeah, okay, now we're back in business. All right, so that's just because of what I did. All right, functional tests, automatic transmission, and we're going to enter that same selection that I just showed you. And here I can select or deselect pits, so, but it's not really so bad because it's not many, and I can make a graph. I like that from a snap-on that you can see it from the distance. So I'm going to command it on. When I'm doing this test, the computer will be cycling the relay on and off. And that is the way this test in this menu works. And I want to show you the other one after this one. So on, you can see the relay on and now being commanded off and on. And now we can see the cycling of that test light on and off following the commands of the computer. So how is this computer? Perfectly good now, because it's doing exactly the response of the command that the snap-on scanner is sending through the network, and the computer is following that command, right? So everything is good in here. So we're going to turn it off, and we're going to exit this test. Now we're going to go at the bottom, the last one that says, well, it says all solenoids and relay. That's the one I wanted to use, because when I'm using this one, the computer is actually, or the scanner is commanding mostly the solenoids, and the relays can stay on. So that's what is going to happen here. So I'm going to put the transmission torque converter solenoid, so you will see the solenoid cycling. But in this case now, the ASD relay will be on all the time. Let me just find it because I don't have my glasses. So it's right here. Okay, so let's do now this test, right? Because in here you will see how the solenoids are on and off, because you will say, well, Mike, on that last test that you saw, is it the scanner commanded it on and off, or is the relay circuit failing? That's exactly what I'm doing this one, and I'm going to show you the no. That's the way the computer is doing it, so it doesn't overheat the computer itself or the relay. But in this one, since the solenoids are the most important, you see that the one on the right is the torque converter solenoid is being commanded on and off and on and off and on and off. But the ASD relay is staying on. Why? Because that's what the scanner is commanded it to do. The computer is sending mostly in here solenoid tests, and you want to have on and off to make sure that it can be turned off, and also on to make sure it can be command on. That's why in the order a specific test for the ASD relay, it was commanded on and off, on and off, and on and off. But I want to show you here, Dustin, that test light is nice and bright. It's not flickering, and now it's fully on. I also can, not sure if I really want to put an oscilloscope, and you can, let me just go back to this view so you can see me better. You can connect an oscilloscope and see exactly what the computer is doing, or if the relay is being pulled down completely to ground. I don't think I really need to do it in this case. Why? Because I have a load, I have actually a bigger relay, and I can hear the actual coil being closed, the contact, sorry, being closed, and it's steady. It's a click and click. That's it. When I turn this off, I can hear the release of the switch internally in the relay, right? We have a contact in there that closes and open. And when I close it, I can hear the click immediately, and we can see how it's staying completely commanded on. That light is not flickering. That light is not, coming on and off, which when you have a bad relay, like in the case of Dustin, is exactly that, the buzzing of the relay. If you would have to put, a test light at that moment in there, you would see the flickering on the test light because it's not being completely pulled down. And that is his problem. Obviously, no longer present. And that's what I'm doing this test, because I want to show technicians, and you are watching this video, how you can do this test, and also to prove that my repairs are fully done and the computer is fully operational. So in the vehicle, with this view that I gave you before, let me take the meter and you can do the same thing, because what I was saying in the beginning, what if the harness is bad? Okay, you need to remove the harness, but not completely. Okay, you will disconnect the harness. In here, we need pretty much the 3 connectors. So what would I do in the case of doing a test like this on the car? Well, we have technicians, specifically test leads like this. Let me show you. All right, this is from Picoscope. So let me go back to this view so you can see it better. This is from Picoscope. This comes with the multimeter, with the oscilloscope, the 4425A, the master kit. But you can buy this separate. Was the ASE Wave. I have multiple test leads kit. So what this has inside is this. So this is a whole lot of test lead that I can use for connections, right? So what I would do in the car, let's say, these are round pins. So this has a male, put it close to you. You can see it from there. It has a male side and a female. And then a 4mm connector, perfect, because I can put my multimeter here. I can put a test light in there. I can put whatever I want, right? As long as it's 4mm banana adapter. And I have made all my connections like that. So my oscilloscopes and everything are already, and the multimeters come with that same size. So what will you do in here? So, well, you unplug the connector on the vehicle. The connector on the vehicle is going to have female terminals. Okay, well, now I can put the male terminal of this connector that I have here onto the onto the engine harness or the vehicle harness. And then the next pin into the computer, I'm going to go into connector 1, pin 22. Let me just go now over to that view. And now you can see me. So how I will start, because I only need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 connections. That's all, and I will remove the harness or be able to test the harness, because by me doing this, I will isolate everything else as far as loads and sensors, right? Because all I will be providing to the computer is what it needs to be talking. If I provide this and I still have a problem, then I have to, with an oscilloscope, now I can measure here and see what am I missing. Is the battery not the proper voltage? Is the terminal 87 not being commanded or going through that ASD relay proper, and the computer is not powering on? Or is the ignition, or is a ground? So I can do my test. But so if you follow, what do I do? Again, male side to female connector on the computer, on the harness, and now the female into the computer pin, which is a male side on the connector on the computer. I make my test, and now I have this very beautiful 4mm banana adapter in here that I can plug my oscilloscope, I can plug a test light, and do exactly what I'm doing in here, right? So I can put a test light, I can use a relay, I can do everything. So the way that I have this relay connected, let me just put these tools away. And you can use this test on any vehicle. I love this kit, because this has pretty much all type of connectors that you can use into almost every car, out of domestic, Asian, and European. So the relay, if we go back to the relay diagram, let me go back to this in here. So what is this relay needs? Okay, so we're going to have, coming from the computer, the C3, which is the ground control, right? That the computer provides that. Well, we already got an ignition in there. So as the same way the computer is, the vehicle is doing on a splice, I can use another wire from that same connection that I just did, that goes over to C12, which is ignition, and I can put that into pin 86 into our relay, right? So now I have that power. I can even use that same power to terminal 30, which is also a power, because I don't care where the power is coming from. All I need is to have battery voltage on those 86 and 30 for the relay. And then I can put a test light. That's what I would do. Okay, where we're talking about this point in here, 86 and terminal 30. And then on 87, what I would do is I would put a test light here to ground. So when this power goes or closes in here, and this power goes in here, that test light has to light up like I have in here. Or if I don't want to use a test light and I want to use an oscilloscope, I can keep the computer connected and then see if when the relay closes, that voltage goes high, which for me, the test light is the best because it's visual, it's easy. You can see it from inside the car. You turn the ignition on and you know if it's working or if it's flickering. You can hear that the relay is the relay now that you install and they're not buzzing, and the one in the car is buzzing. Well, something in the harness, right? Because that relay is, that automatic relay is in the PDC, right? So it's in a fuse box. So it's the harness between the computer in between this computer and that relay. The problem am I, because this relay is not buzzing and I'm providing pretty much the same thing right here. So something else is in there, you see? So I'm trying to give you a lot of tools, simple tools that you can use. And you can, if you want to create your own jumpers, like I do. I mean, I buy a 4mm. Show you. I buy my own rolls of wiring from Amazon, and I bought this solderless because these are. It has let me show you in here. This is the 4mm banana adapter. So what I'm showing you in there is how I do my harnesses in here on my test light and everything. Everything you see there, I have built myself, except for those test leads that, you know, Picoscope has, and that come in the master kit. But as you see, I have it saved, and I'm using some in there because, I mean, I have it. So I use it. But you can make your own connections, your own terminals, and everything will be working really good for you without spending too much money. Again, these are solderless 4 millimeter banana adapters that you can buy in Amazon in package of 20. They come black and red or multicolor, your choice. And the wire that I'm using in here is 20 gauge. And the reason I use those is because it's very easy to solder, very easy to use. I don't need, you know, anything heavy, and I have all the other wires that I use, but this one can manage up to, I think it's 10 amps, which is most of the automotive. That's exactly what you're gonna have, right? So even if you have a 30 amp fuse in there, the fuse in there at the top of this harness, or sorry, diagram that I show you here, this one, it says 30 amps. It's not just because the computer needs 30 amps. No, it's just because it's also because that will probably be supplying power to something else. And we can see, you know, this has a joint connector. So it's not the whole thing. We're not seeing the whole reality of what is connected to the circuit, right? All right, guys, and Dustin, I don't want to take much longer of your time. I hope that you like the content. Like I said, I'm not just trying to repair something. I always show in my videos the full test and the wire integrity test. You can see that relay is still on. Everything is nice and bright on that light, and it's being on for all the time that I've been talking to you guys. All right, guys, if you're here in the channel, please don't forget to subscribe. If you have any automotive or marine computers, instrument cluster, please contact me. I'm going to put my website on the title of the video so you can copy and paste it. A lot of people ask me how my name is spelled or it sounds. My name sounds Mike, just a regular Mike that you will, you know, type as M-I-K-E. Mine spells very different. It's because I'm originally from Costa Rica. My name is spelled M-A-I-C, but it sounds exactly like Mike. All right? I'll see you next time. Don't forget to subscribe. Bye-bye.